In this video, we're going to talk about a useful property of the terms of a convergent series. Let's start by recalling that the nth partial sum of a series is the sum of all of the terms up to the nth term, and that we denote this by S sub n. Let's suppose that this series converges to S. Then the limit as n goes to infinity of a sub n is the limit of the difference between S sub n and S sub n minus 1. By the limit law for a difference, we can split this into two limits, since both of these limits exist. In fact, they both equal S, so their difference is 0. In summary, if the series converges, then the limit of the terms of the series equals 0. To help clarify what this does and doesn't say, let's look at the rain cloud theorem. This says that if it's raining, then there's at least one cloud in the sky. Clearly, it's not true that if there's at least one cloud in the sky, then it's raining. In general, the statement if A, then B is not equivalent to the statement if B, then A. Sometimes they're both true, but they're not equivalent statements. The statement if A, then B is actually equivalent to if not B, then not A. In the rain cloud example, this translates as the statement if there are no clouds in the sky, then it's not raining. Let's go back now to series. Remember that if a series converges, then the limit of its terms equals 0. If we switch the order correctly, as we did with the rain cloud theorem, then we get the nth term test that states that if the limit of the terms of a sequence does not equal 0, then the series diverges. This is also called the divergence test. Let's look at two examples. Since the terms of this series approach 1 and not 0, the series diverges. Another example is this series, whose terms alternate between 1 and negative 1. In this case, the limit of the terms doesn't even exist, so it doesn't converge. We should make three closely related remarks. First, the nth term test can never tell you that a series converges. Second, it can either tell you that a series diverges, or it can be inconclusive about whether or not the series converges. Third, to determine that a series converges, it doesn't suffice to show that the limit of the terms is 0. For example, the terms of the harmonic series converge to 0, but this series diverges.